Now, of course, this is an college algebra class, so one of the things that we tend to do is solving equations. That's a big focus of college algebra, is how to solve different types of equations. Back in Unit 2 is our equation solving section. So we did linear, quadratics, radical, rational, and then we actually did inequalities as well. Oh, and absolute value. We did all of those, solving those types of equations. Now in 7, we're going to introduce the exponential and eventually the logarithmic equations and how to solve those. As we get to like the equation solving section in this chapter, we're going to solve like basic versions along the way. So in 7.1, we're going to look at basic exponential equations and how we can solve them. So you guys have this in the notes that I have made available to you. But an exponential equation is going to be an equation where the variable of interest is inside an exponent. Up to this point, our variables have been raised to different exponents maybe, but so like we could take square roots of stuff, we could multiply, but the variable itself wasn't the exponent. So that's going to be what's different. Now, because we're doing exponents, I'm going to go ahead and remind you guys of the laws of exponents real quick. If you multiply matching bases, you add the exponents. Negative exponents make reciprocals. Power to a power means you multiply the powers. And anything to the 0th power is 1, anything except 0. Now, I don't think I need any other laws for this section. But if I do, I'll just add them in the notes and you guys will see them. Okay, so here's the fact that we're going to be using to solve equations. If a to the m equals a to the n, then m equals n. So what that means is if I have the same thing raised to 2 different powers, it must be the case that the powers are equal. So let's start with a basic example. Oh, this lets us equate exponents and is a way to solve basic equations. All right, so let's look at our first example of this. Solve the following if possible. 2 to the 2x equals 4. All right, so I have 2 to a power equals 2 to another power. So whatever 2x is, it has to be equal to 4 because when I raise 2 to the 4th power, I only ever get 16, right? Nothing different ever comes out. So I'm going to equate exponents. All right, so this means 2x equals 4, and guess what? Just like in chapter 2, what we've done is we've taken an equation type and we've turned it into something linear. This is section 2.1. So all the way back in 2.1. So I divide both sides by 2, I get that x equals 2. For exponentials, they have a domain of negative infinity to infinity, so you don't have to worry about domain stuff here. So this solution should be correct. So solution is just 2. All right, of course, you guys get calculators. You can check this, right? There's no reason not to check this on a calculator. So on your calculator, there may be different ways that it does powers. So on mine, I have this x to a box button, and this actually is my, like, any power button. So if I want to check 2 to the 2 times x, so here I found that x was 2. That's 16, and I know that 2 to the 4 is also 16. So this is a true equation. Some calculators, I'm not sure if I have one with me at this moment, but I will get one, don't have a button that looks like this. They have like a caret button. So if you look at the 6 on your keyboard, Shift 6 is the caret. Sometimes that's how calculators do powers.